Okay, hello everyone. Welcome to the event. Thank you so much for joining us. I can see the participants entering now. Really exciting. I'm just waiting for the numbers to go up just to make sure that everyone who's waiting is here. But as you're coming in, just so you know, we're going to give it a couple of minutes before we start. And then I will introduce everyone and everything. Great. I can see oh wow, there's up to around 30 of you here. So that's super exciting. Okay. Yeah, just to reiterate, if you just joined and you didn't hear the first part, we're just going to leave it a couple of minutes to give people time to join. Welcome to the event. We're really excited to have you here, really excited to be talking about the community. Any questions, you can pop them in the Q&A. But yeah, looking forward to starting. Okay, I've just had confirmation from the team. They're in another room watching that they can see us, and we're about 4 minutes in, so I think we're probably good to go. Yeah, so really excited. Thank you so much for everyone who's here. I can't see the total participant number at the moment, but Jack, what can you see? What's it on?
39.
39. Oh, wow, amazing. Thank you so much, everyone who's joined us today. Yeah, we're really thrilled to be talking about our community and the ways that you can get involved. I'm going to do a welcome, which I've just done, and then housekeeping. So we have a Q&A function. If you have any questions, we'll be doing a Q&A at the end. We've got Jack Kelly, our co-founder, and then Peter Dudfield, our head of technology. So any questions you have for them, please pop them in the Q&A box. Hopefully there'll be some interesting topics that spark some questions in your mind as we go through. I'll just quickly run through the agenda. So we are starting off with Jack talking a bit more about Open Climate Fix, Open Climate Fix's mission, why we're open, why we chose to do forecasting, which we'll learn a bit more about as Jack talks. And then we will move on to how you can actually get involved from the community side. So firstly, I'll talk a bit more about those who have technical skills and how you can get involved. And then I'll give some options if you're not technically inclined, but you're still really interested in maybe learning about open source or learning about energy and climate. And then we will end on the Q&A, which is really exciting. So please think of questions. We really want to hear your thoughts and suggestions and ideas. So without further ado, I'm going to let Jack take it away, and I'm going to stop my video. And I will see you in a bit.
Cool. Thank you very much, Emily. So yes, hello everyone. So as Emily says, I'm going to talk for about 10 minutes or so, giving an introduction to how OCF started and why we believe so much in doing things openly and why we focused on forecasting. So I'm Jack. I'm one of two co-founders of Open Climate Fix. You can see Dan, my lovely other co-founder, in the upper picture on your screen. Yes, thank you very much, Emily. So Dan and I first met through a mutual friend back in 2018. At that time, Dan was just starting a PhD in solar forecasting, and I was at the Google DeepMind energy team. And then I left DeepMind towards the end of 2018, and we co-founded OCF in early 2019. So I guess the big question is, why did we start OCF? And that is intimately related to why we open. So next slide, please, Emily. Thank you. So to explain why we're open, I need to give a little bit of sort of historical context. So in both Dan's previous employment and my previous employment, we'd both been involved in projects where our then current employer wanted to collaborate with an external company, hopefully to do something that was useful for the climate. And these collaborations might start with a handful of meetings with just the technical folks from our employer and the other company. And we get all excited about all the amazing things that we could do together and all the problems that we could solve. And then, of course, the lawyers would get involved and the project would come crashing to a halt even before we'd actually done any technical work. And we both found that hugely frustrating. And to give a bit of context as why that's so frustrating, certainly for me. So I think that the humans alive today are in an amazing position whereby the decisions that we make today will lock in or could potentially lock in climate change for tens of thousands or maybe even hundreds of thousands of years. So I have this image of someone maybe 2,000 years from now with 20 meters of sea level rise, looking back to us, the people that are alive in the early 21st century. And this person in 2,000 years' time is asking, why on earth didn't they solve climate change? And of all the possible answers for that, saying, oh, well, we couldn't negotiate licensing terms just seems so comically stupid that I was sat in these meetings with collaborations, just feeling almost sick to my stomach that we couldn't get this amazing project off the ground because we couldn't agree licensing terms, and that could have a small but significant climate impact. And that made me feel very sad. And so that really got me thinking that, well, maybe if we had a non-profit that explicitly didn't care about owning intellectual property, then that would at least slightly help grease the wheels a little bit. So next slide, please, Emily. So there was this general idea that there's this broad problem, that there's this kind of mountain of pain between the energy industry and researchers and companies that are doing innovative work. And maybe Open Climate Fix can help to sort of drill through this mountain of nonsense. So next slide, please, Emily, which is very neatly illustrated by this tunnel going through this mountain of nonsense. And so, so that was really one of the two main motivations for building a non-profit that would focus on open source code and open data, was to help enable collaboration between us and existing players in the energy industry. And a second reason is because it seems to be the case that if we work on building things that, or building tools that other people can build on top of, then we multiply our impact. And so for every hour of work that we do, we might enable 1,000 other people to do great work. And so that's a second reason why I'm really passionate about open source, is that if we can help build tools, and you can argue that for the last 10,000 years, sort of all of technological development has taken the form of building tools, whether it's tools to help with agriculture or tools to help us study the night sky, a lot of technological development has been based on people building tools and enabling other people to use those tools. So that's a very quick overview of why we're open and why we some of the reasons why we set up Open Climate Fix. So now in the next 5 minutes or so, I'm just going to talk a bit about why we focused on forecasting. Thank you, Emily. And the broad answer is it's because we believe that better electricity forecasts can help reduce costs for end users and reduce carbon emissions. So before I explain, there's a lot in that sentence that I need to explain. Before I do that, we're just going to see if we can play a quick video that will give a flavor of the data that we're working with. So here in this video, you can see cloud cover over the UK. This cloud cover is from a geostationary satellite that takes an image every 5 minutes. And then each circle, each colored circle is represents a single solar PV system, and the color represents how much power that PV system is producing. And what you can see from this visualization is exactly what you'd expect, which is that when clouds are over PV systems, we tend to see a big reduction in the power output. And so in a sense, what we're trying to do, or one of the things that we're trying to do in Open Climate Fix, is if you imagine pausing this video, what we're trying to do is take what we've seen in the last hour or two of satellite imagery and use that to try and predict what the clouds are going to do over the next few hours. So that gives a flavor of the problem, but I still need to explain to you why we're working on forecasting. So next slide, please, Emily. Thank you. So one of the big reasons is because certainly back in 2019 and still today, we believe that existing solar energy forecasts are leaving performance on the table. One of the reasons for that is that numerical weather predictions, which are these predictions produced by large meteorological services like the UK Met Office, and they run these huge models on top 10 supercomputers, and these models capture the sort of dynamics of the atmosphere and the ocean and try and predict what's going to happen to the atmosphere over the next few days. It turns out, for a number of reasons, that numerical weather predictions aren't amazing at forecasting irradiance. They're getting better, and I have a huge amount of respect and love for numerical weather predictions. Certainly, if you want to know what the wind is going to do in the next few days, they're probably your best bet. But yeah, there are a handful of problems which make them suboptimal for forecasting irradiance, certainly in the next few hours. So one is that at operational resolutions, so that might be down to about 1 kilometer per grid square, or kilometer between grid squares horizontally, the physics can't resolve clouds. We can go into what that means in Q&A if you want. They also take a few hours to warm up, so and to execute. So the forecasts are sort of necessarily a bit stale relative to the state of the atmosphere. And also just historically, some of the biggest drivers for developments in numerical weather predictions have been defense and trying to get early warnings for flooding and that sort of thing. And those use cases just haven't been that interested in really precise forecasts of irradiance. So next slide, please, Emily. Thank you. So we've been working with National Grid Electricity System Operator to help them to forecast solar energy. And we have a forecast that's been in production for a while now that they can see in the control room and has been helping them. And we believe we're at least 40% better than their existing forecast. And one of the several mechanisms by which we hope that we help National Grid reduce emissions, so next slide, please, Emily, is by reducing what's called spinning reserve. So I'll just take 30 seconds to explain what that means. So every moment, electricity supply must match electricity demand. And we have little control over demand. We have getting a bit more control over demand as the years tick by, but effectively we have very little control over demand. So demand will do whatever it wants to do, and it's up to generation to follow demand. And at the moment, the main way that we do that is with natural gas-fired generators, which look a lot like huge jet engines strapped to the ground and attached to an alternator to generate electricity. And these can sense the grid frequency, and these generators can ramp up and down in response to the frequency sagging or going a bit over. But in order to do that, National Grid needs to say, I want 100 megawatts of upwards reserve, please. And so these generators deliberately run at less than 100% capacity so that they have that headroom. But it turns out that's both carbon intensive and expensive. So these gas generators are less efficient when they're running at less than max capacity. And so by giving National Grid better forecasts, we hope they can reduce the amount of this spinning reserve that's required, which should help save costs for end users and also save carbon. And just to give a flavour for the costs involved here, a couple of years ago, the total cost to balance the grid in the UK or in Great Britain was £4 billion. That's not all down to forecasting error, but a fairly large chunk of it is. So if we can improve forecasts, we can significantly reduce these costs. Right, I am at the end of my little piece, so I should hand back and I will go back onto mute, and then we'll have a Q&A session at the end of the whole session. Thank you.
Thank you so much, Jack. Okay, I'm back. So I'm going to now talk a bit about, if you guys have any questions, just a little reminder that you can put them in the Q&A and we will get to them at the end and answer as many as possible. So I'm now going to talk a bit about how you can get involved with the community and what activities are up for offer. So firstly, I'm going to talk about it from the technical side. And I'm going to start off by talking about our GitHub. So we have our GitHub, the link is on the screen. I'll share these slides after with everyone who attended, but I'm hoping that people might have checked it out before. Essentially, we have a list on GitHub which is called Good First Issues. It has a wide variety of issues which we've created. They're mostly small, mostly manageable. We really wanted to make sure they were available for people with a range of machine learning and software engineering experience. So if you are interested in working with Open Climate Fix and contributing to our open source code, then you can go onto our GitHub, head over to Good First Issues, and essentially find an issue that you think looks interesting, comment on it, tag Peter Dudfield, who is our head of technology. I put his GitHub tag on the screen as well, or you can start a thread on our GitHub discussions page and open a conversation there. So that would be our first recommendation for how you can get involved with contributing to Open Climate Fix. I'm just going to talk a little bit about what you would actually be contributing to. So I know Jack talked a lot about the background of OCF. And I'm now going to talk a bit about what that's kind of formed into. So our main project is Quartz Solar, which is our AI-powered solar forecast. We use satellite imagery to produce highly accurate solar energy generation forecasts from minutes to hours ahead. And I have a really nice video, which I'm hoping is going to work because the other one was a bit jolty. And it looks like it's also going to be a little bit jolty. But this essentially has, oh, there we go. You can see the solar generation across the UK here. You can see down here, London's very grey, which is not surprising. And then you can see our predictions on the side. So a lot of the issues on GitHub will be contributing to working on our Quartz Solar model and project. If you are interested in that, then you can scan this QR code and sign up for free today to test out Quartz Solar. We're always looking for feedback, so we'd love any feedback that you have about that, and also any questions you have about it. Obviously, drop them in the Q&A because I'm sure the team will be able to answer them at the end. Okay, and then moving on, we also have our site level forecast. So you can use our Quartz Solar code essentially to create a more localized version of that forecast. So there's multiple reasons that you might want to do that. So some practical examples of it are if you have solar panels or battery storage at home, you can use this forecast to help optimize your energy. So for example, if you have an EV, you might want to charge it at a time when it's the lowest cost to you, and you can use a high amount of solar generation, and our forecast can help you time manage that more efficiently. Another interesting way that our localized site level forecast can be used is it's a really useful tool essentially for smart home operators who'd like to participate in the energy flexibility markets. So Jack spoke a little bit about kind of the demand versus generation problem that we have, essentially talking around how there isn't enough renewable infrastructure to support electricity demand from consumers. So energy companies will provide incentives to use power at certain times, which will help you manage the demand. So for example, if you're with Octopus, you might be part of their flexible rewards program. So smart home operators who have access to multiple households can use our site level forecast to help manage flexibility on the grid. The site level forecast is also really useful if you're a researcher or an academic, or maybe you're just a hobbyist and you're looking for localized data on a certain area around solar for your specific needs. So I've put a little QR code here as well, so you can scan that. It'll take you straight to GitHub for this specific open source Quartz Solar link. And you can see here an example of what the output will be of that. And then finally, we have on the technical side, you can obviously use our data. So energy data is notoriously really difficult to obtain and really messy to work with and not easily shared. And like Jack mentioned, that was a huge issue that was identified and what kind of inspired the start of Open Climate Fix. So we share as much data as we are legally able to, and we really want to encourage experimentation using our data sets. We have on Hugging Face, I've also put our Hugging Face link at the bottom down here. We have our PV data set, which has 25,000 sites of PV data and around 15 years worth. And then we also have our Google public data set. And on that, we have 10 years worth of satellite data. So examples of how this can be used or how it's been used in past, we did an open collaboration with Trio Labs, who are an impact lab. They're focused on practical adoptions of AI. They ran a little experiment using our PV data set. They wanted to see if they could improve the predictability of our site level forecast. So to boost the performance, they replaced the previous gradient boosting model that we were using with the XGBoost model. And you can see the results of that here. So the model was trained and validated on data from 1,147 solar power panels, which came from our data set, and the prediction error decreased from 0.19 kilowatts to 0.12 kilowatts on the test set, which was an improvement of 37% compared to the original model. And that's a really fun, interesting example of what you can do with the data and how it can be used to collaborate with Open Climate Fix and improve our work to make sure that we transition faster to the greener grid. So the other, I also wanted to add, actually, there are other ways that you can use the data. There's someone in our community who used our satellite data to create a forecasting model for Swedish rainfall. So there's tons in there, would really recommend checking it out. And if you do use our data and code, we would really appreciate if you could credit Open Climate Fix for any external projects. So you can simply just say original code by Open Climate Fix. And we would also love to hear about it. So you can share your success or any interesting projects that you've done on our GitHub discussions page, or you can email community@openclimatefix.org so we can shout about what you've been doing. So how can you get involved from a non-technical side? There's still a bit of interest for technical people as well. But essentially, we're really excited to share that we're going to be running some events in the upcoming months. So firstly, we're going to be launching a series of tech talks, which we hope will be really useful and educational for the community. We'll be looking around the core of what we are at Open Climate Fix, so open source AI and climate. And we're hoping to encourage lots of discussion and collaboration through those online events. So we would really recommend signing up to those if this is a sector that you're interested in. We also are going to be running open office hours. These will be online as well, so you'll be able to ask the team, you'll be able to get advice on an issue, or share an idea for a research project. We're a really friendly team, so I would really recommend coming along if you have any questions or you're a bit nervous about open source, maybe you've never done it before. So yeah, that's a really good way to kind of get started in it. And then we have our GitHub discussions thread, which I've mentioned. If you aren't technical and you don't know what GitHub is, although I'm assuming most people on this call will, it's where we keep all of our code and you can access it through there. But there's also our own little forum on our GitHub page. So you can start conversations and ask questions and interact with the community. So we'd recommend heading there. And then, of course, we also have our Quartz Solar feedback. So you can test out our forecast, provide feedback. We'd really appreciate any comments so you can help support our mission to transition to the greener grid. And now I think that's it from me, I'm pretty sure. So it's the Q&A side. I'm going to stop sharing my screen. And then if Peter and Jack want to turn their videos back on. Hello, welcome. Okay, I can see we've got 7 questions in the Q&A. Very exciting. I'm going to start off with one that we had submitted earlier. So, okay, for Jack, are there challenges around compute power to train your models? I imagine Google DeepMind would have a lot of compute resources.
Yes, there are definitely challenges, and yes, Google DeepMind definitely had a lot of compute resources. Yes, we are definitely always hungry for more compute, more GPU compute, although also conscious that we don't want to use so much that starts to become an energy hog. So we have 6 NVIDIA A6000s in our on-premises server. And we also make a lot of use of both Google Cloud and AWS. And Google Cloud have been very kind and given us a whole bunch of free credits, which have certainly helped us enormously. And all of those NVIDIA GPUs were also given to us for free from NVIDIA, of which, of course, we're hugely grateful to NVIDIA. But yeah, in general, to your point, more compute is always going to be better. And actually, it's also data storage and data processing that's also a challenge, not just training the models.
Okay, thank you so much. And then a question for Peter. What is the highest impact area to help out on? So where would you recommend that people go? Do you have any tips on that?
Yeah, I think it completely depends on your skills and different. People have a variety of different skills. But the first port of call, I think, just if you go to our GitHub and the good first issues, there's lots in there to hopefully help out on.
Oh, sorry. Do you want to go, Peter?
No, that's all good.
Okay, and then we have a question. Are you planning to open source the code of the winner solutions at the climatehack.ai competition for solar power forecasting?
So maybe I could take that one.
Yeah, I think that's
yes, we totally are. We actually don't have the code. The competitors have their own code, but we're trying to encourage the teams to open source their code. And actually, it's a great example where their models could be integrated to Open Quartz Solar and into that site level modeling.
Okay, thank you. And then actually, I think another community focused question, which would be good for you, Peter, is the community involved only with PV, or are they also able to work on wind or other energy sources?
So we've I guess at Open Climate Fix, we focused on solar, and at least initially. We've expanded to doing some wind in India at the moment. So we're not restricted. We definitely could open more and do some expand away from solar. Just as we've started, we've kind of had that focus. So if there are some wind or other sorts of energy kind of enthusiasts out there, then yeah, get in touch, and we should start talking and do some fun things.
Okay, we have a question from Sam. Are there energy-related forecasting problems other than solar that you think are currently underserved and potentially are high impact?
I can have a go at answering that, and maybe it also helps to answer Matthias's question about forecasting demands. So yeah, so to Peter's point, we have also started exploring wind power forecasting. I'm also really interested in forecasting demands, electricity demands, that is, both because it's ultimately what most people that consume energy forecasts are interested in. So ultimately, for example, the grid operator is interested in keeping supply and demand balanced, as Matthias says. And so, yeah, ultimately, they're looking at that total demand number. And also because my hunch, this is completely a hunch, is that sort of what you might call modern machine learning might well be particularly well suited to improving demand forecasting. So I did a bit of work as a consultant with National Grid ESO and built them a demand forecast based on the temporal fusion transformer, or actually a simplification of the temporal fusion transformer. So it's quite a simple model. It's a small recurrent neural network that then plugs into a small encoder only transformer. And that worked really well and worked better than the commercial provider that ESO were getting their demand forecast from, and was in production for a while, and I think probably saved a fair amount of money. And yeah, generally excited about continuing that work, because I do think though these models can suck in so much data that will tell you information about demand. That yeah, in general, I think forecasting demand is particularly interesting. Peter, anything to add? Or
Okay, great. So thank you for that question. And then we also have a question from Tim, which is interesting. Have you thought about using compute in CoLoS-based in swimming pools?
I can take that if that's. Oh, sorry, go on, Peter. So yeah, so we have spoken to a couple of companies. Well, actually, I think maybe a total of 3 companies now. One which wasn't doing swimming pools, but it was doing sort of taking the heat exhaust from compute and using that for domestic heating and heating at kind of community level. We've also spoken to folks who have data centers that are sort of associated with wind farms, and so instead of curtailing the wind farm, you use that excess energy to run the data center. We've done some quick experiments, and so far we haven't gone down that route, largely because we're a small team and it takes a lot of effort on our part at the moment to lift and shift our compute loads to these new systems. But yeah, in principle, it sounds like a great idea. But also, it's probably important to note that the energy footprint associated with us training ML models is pretty tiny compared to like training a modern LLM or something. Anything to add, Peter?
Just small, yeah, it's a small thing to add. It was I think what stopped us, particularly at one site, was with the data, the large amount of data that we use needs to be very close to the model to kind of speed up that iteration and training the model. That you have to move that data as well to these different sites, and that can also take time. This is kind of I think we're up to like 100 terabytes of data, and certain things. So that was a slight blocker, but that doesn't mean in the future that we can't solve that.
Okay, thanks both. Peter, I think I've got another one for you here from Doug. So aside from picking up a good first issue, is there a good resource for getting a minimal setup running so we can get a better idea of where it's feasible to help?
Thanks, Doug, for the question. That's a hard one. Generally, our code is Python based, so that's kind of what we've been using to get things going. It completely depends where you want to help out and your skills. So it might be send me an email or drop me something, and we can work that out.
Yeah, or you can attend one of our office hours as well and ask the questions live. I actually want to share that the first office hour will be July 2nd. So I'll send a link to RSVP for that if you're interested in an email following this event. Looking at the questions, we had a question about, are you aiming to mainly focus on the UK or are you looking to extend to other countries? And if so, can you provide a high-level view of what it would take to adapt Quartz Solar to a new country?
Maybe I can take that. Yeah, we're definitely looking to expand. Most of the team are in the UK, but we can only have a certain amount of impact in the UK. So that was one of the reasons to expand to doing some projects in India, and we're using the same model there that we do in the UK. I mean, it's retrained. So we want to expand as much as possible. Essentially, it's data. So we need to find what we're trying to predict for, and in certain countries, the data availability is a bit tricky to find. The wind generation or the solar generation of countries or regions is maybe not so open. Of course, we're using NWPs as well, so these kind of big weather predictions. Some of them are available globally, so that would be, there'd be a point of collecting all those for that certain country, or using some of our global weather data. For example, we've shared some icon data on our Hugging Face that is global, and it's a nice kind of back catalogue of all their forecasts. So that's probably a quick setup. We use satellite imagery as well, so they'd be kind of collecting that for the certain area or the certain country the project would be on.
Thank you, Peter. We have a question from Richard. So for people with backgrounds in machine learning, but limited or no experience in energy, do you have any good recommendations for reading or courses to get up to speed on power systems or energy markets? Maybe I can give you time to ponder it.
I feel like, Jack, you did a seminar or a online something that might help.
Yeah, thank you. Yeah, no, there's a climate change AI online course that I contribute to that I think probably is exactly targeted at that question. This doesn't exactly answer your question, but I'd also highly recommend offering your services as a consultant for like 6 months or so at an energy company, because there's really no substitute for actually being on the ground and actually working in an energy company like a grid operator or something like that, and really seeing the problems firsthand. Because I think one of the challenges that we have in the kind of climate change for AI, or AI for climate change sphere, is it's fairly easy to come up with a long list of potential things that we could work on, but whether or not they'll actually work out in practice is one of the big questions. And so having real experience with what the actual industry are interested in is always really useful. So it might sound scary, but I think in general, energy companies would lap up folks like you that have machine learning experience and an interest in energy. So I definitely highly recommend that. And yeah, there's definitely this climate change AI MOOC that's available.
Okay, I think we have time for just a couple more questions. So Luke has asked, do you regularly have to retrain your deep learning models for predicting solar generation, or are they pretty robust after the first train?
So they're pretty robust in the idea. We do some normalization that helps us there. Solar energy, particularly in the UK, is growing, and other countries is growing as well. So if we normalize kind of to capacity, then hopefully we don't have to retrain as often. And if we're kind of essentially predicting weather or like predicting cloud movements, we hope, although things do day to day are different or month to month are different, hopefully those kind of dynamics are the same. We're probably in enough, there's enough new features, enough new kind of research ideas that we do retrain fairly often, but more for the, implementing those ideas and reducing the accuracy, rather than kind of some people retrain their models every day and deploy them. We haven't gone down that route.
Amazing. And then we have a question from Bikram. So do you use NWP or numerical weather prediction, in case people aren't familiar, in your current forecasting models, or is it purely based on satellite imagery?
Yeah, so both. So satellite really helps for those first few hours, and we've got to use NWPs, and we actually use a variety. Like the more NWPs you can use, or you're able to use, the better. And they help out on the 4 to 24 or 4 to 48 hours. They're very useful. We try and use, again, as much as possible, so they come in these gridded kind of formats, and trying to pass that all to the model so the model can understand what's important and what's not.
Amazing. Okay, well, I just want to say a massive thank you to Jack and Peter for answering the questions and speaking in this webinar. I hope everyone found it useful or interesting. If you do have any follow-up questions, you can reach out to us. The community email again is community@openclimatefix.org, or obviously you can comment on our GitHub discussions thread. And yeah, we're really, really excited to be doing more with the community and looking forward to interacting with you all as much as possible. Okay, have a good afternoon. Bye, everyone.